Now I see the recording started.
Okay, thanks, Eric.
Okay, let's start again. So this session is about multi-system. So the agenda is this one. We're going to have an introduction on multi-system architecture, even though we already saw something in the Antonio's presentation just before. After that, we're going to see what changed from a functional perspective, so what differences we have in web pages. And we are also going to have a short introduction about dynamic BFF. The third topic is system configuration. So we're going to see what changes we had to do to the configuration in order to have multi-system working. Again, something was introduced from Antonio. We're going to see it a bit more in detail. And then we are going to have an exercise. So we built an example to show you how to configure an exchange station between systems. At least we're going to see, let's say, the relevant steps to make this configuration, not a whole complete new configuration of the system, but the relevant steps for the exchange station. And last but not least, we're going to also have an overview about known constraints and limitations we have on multi-system today. Okay, let's start from the architecture. And let's start with the first question. So why we need multi-system and why we delivered we released multi-system. Okay, the target of multi-system functionality is to allow incremental deployment of new parts of existing plants, existing warehouses, without affecting the already existing production, or with minimal effects on existing parts of the warehouse that are already in production. So let's suppose we have a warehouse that we already delivered to the customer with an already existing fleet, and as let's say, as it's going to happen in our first use cases, like Red Bull, we are gonna have to deploy a new part of the plant. In Red Bull, for example, we need to deploy the layer picking area, and we need then to build some new configurations in Smart, because we are gonna have new segments, we're gonna have new resource types, and we need to work and to test what on the new parts of the plant. Multi-system allows not to do everything, all this job in a single Smart instance, but to add new Smart instances, new system instances. Then we're going to see what we mean by system, without affecting the already existing one. Okay, so a system, as we can see here, actually is a group of applications that are Smart Service, Smart Events, LGV Manager, and the Layout Service. So when we have this cell, let's say, of applications, we are able to control a fleet. Then, that considering, for example, the use case of Red Bull, we need to deliver a new part of the plant. We need to deliver a new fleet with ends. The use case of multi-system is that we are going to install a new system, so this group of services. We can configure them independently from the existing services, and so we are able to work to do all our test development and test activities without affecting production. Okay. Now I've been mentioning two systems, so the first and the second, but actually there is no physical limitation to the number of systems that we can deploy. So we built a multi-system functionality to be able to add to have one, two, or multiple systems in general. The limit currently is the whole sites of the fleet that we are gonna manage with our SMILE application. So because SDM it's still one and it's not gonna scale in the same way that Smart and LGV Manager are scaling horizontally here, then we have to keep in mind that the maximum number of LGVs that we are gonna be able to handle needs to fit in the SDM capabilities. Okay, so we took as a reference the biggest project that we already had. That was around, if I'm not wrong, 100 LGVs or so, and that was our reference. So, for example, in Red Bull, if I'm not wrong, we already have 60 or 70 LGVs in the plant. We are gonna add something like 10 or 20 ends. And so the whole number of LGVs that we are going to handle, and consequently the number of missions, it's still below let's say the limit of the biggest projects that we already delivered. So having one SDM instance only, it's from one perspective is a limit because it's not scaling, and so it can become a bottleneck in case we want to add multiple systems. It's also an advantage because single SDM instance is able, without new developments or without any particular rework, then to handle missions that are across a system. And this then we will see when we are going to talk about the exchange station in few slides. In this picture, then, we see also two other actors. One is the BFF layout, and the other one is the truck loading system. They are here because, okay, BFF layout, let's say it was already there for the handheld, but we also introduced it to interface to let's say to load the data from the multiple systems. So we're going to see more details later, but it's currently replacing the already existing BFF LGV system. Okay, and it allows to make requests to the different systems and to aggregate the results. The truck loading system is here because the communication between truck loading system, SDM, and LGV manager instances has changed. So in previous versions, we had one component called SDM middleware that was in charge to translate between XML and JSON to make LGV manager and SDM being able to communicate with the truck loading system and vice versa. When we introduced multi-system, we decided to remove the SDM middleware and to make both SDM and LGV manager be able to directly communicate in JSON for some messages and being able to directly communicate with RabbitMQ topics, so queues that support the routing key. This was necessary to simplify the whole architecture and also to avoid that some components like SDM should take care about, let's say, dispatching the messages both to all the LGV manager instances and the truck loading system. Now, this kind of functionality is handled by RabbitMQ that is able to distribute messages, and so we have been able to simplify and to make our system more robust. So, for example, SDM publishes shipment events when a shipment changes status. Before, it was both publishing this event to the LGV manager queue and the queue handled from the SDM middleware. Now it can simply publish the same event on a topic, and RabbitMQ is in charge to distribute to all the systems and the track loading system that are, let's say, interested to that topic. Okay, so we have been able to simplify this kind of communication. On the other side, communication between SDM and LGV manager didn't change. So they both exchange all the messages that you already perfectly know, like add mission, modify mission, pickup, and so on. All those messages are, keep the same way, let's say the same communication schema. So they are exchanged directly via queues. And we're going to see later in the configuration, the only thing that changed is that SDM publishes the messages to the queues per each LGV manager, while LGV manager publishes all the instances of LGV manager publishes the message to a single queue for SDM. Okay, we're going to see later in the configuration, and probably it's going to be more clear. Okay, then what changed from a functional perspective when we introduced a multi-system functionality? The good news is that from a functional perspective, nothing changed. So all the functionality that were already there from a user's perspective are the same. Nothing has been removed or nothing has been added as functionality. What a user is going to see different now is that in all the web pages that are related to the fleet, basically, and to LGV manager. So, for example, the page that shows the list of the LGVs or the active location or the active missions, all these pages now are enriched with one more information. That is this new column that you see, for example, here in the LGV list page. And this new column provides information about the system ID. So what is the system that is handling, in this case, for example, the LGV? This was necessary because we didn't want to provide, let's say, constraint, for example, on entity IDs. So it's possible that the same, let's say, two instances of Smart have both an LGV with ID 01. And so here we need to be able to recognize the two LGVs that have ID 01. And that's possible via the system ID column. Another thing that changed from a user perspective is in the actions. So when we see information, we have a column more. When we want to execute an action, action on entities are the same because I'm selecting a specific entity, and so I'm also selecting a specific system. But when we need to execute actions that are on a whole system, for example, starting the missions or putting in pause the battery missions, those are actions that involve a whole system. For those actions, we have to select the system we want to perform the action on. Okay, so we can pause, for example, battery missions, but we have to specify if we want to pause for system 1 or for system 2. One thing that I forgot, we see better when we see the dynamic BFF, but when we retrieve the data, so like here in this LGV list page, we are able both to retrieve all data from all systems, or we can also filter and see the data we can also filter by system ID, let's say. So we can also see only the data from one system or the data from the other. Okay. Okay, here let's take a look then to the dynamic BFF. So this slide is a bit crowded because there are a lot of information here, but let's say they are all in the same context, so I wanted to put them together. On the right, you can see the whole list of pages. I took it from the developer guide, so you can also look in documentation. But here you can see the whole list of pages that changed because we added the system ID column or because the actions have been modified as we just discussed. Okay, so you have that kind of information. Then also for this slide, I would like first to explain why we decided to use dynamic BFF in this context when we introduced multi-system. So before having multi-system and before having dynamic BFF, data from LGV Manager were retrieved using the backend for frontend called LGV system. And this backend for frontend basically was in charge to retrieve the data from the LGV Manager by invoking some WCF endpoints. Okay. Now with multi-system, or also invoking some queries directly on the database in some cases. Now with multi-system, things became a bit more complex because we had to take care about data aggregation from multiple LGV managers. So even though at first sight it looks simple, then when we consider that those data can be filtered, ordered, and paged, we can apply pagination, then it becomes more clear that we cannot simply independently ask two systems to filter, order, and paginate data and then put everything together, because otherwise we risk or we are sure not to not to fulfill the user request from an ordering or a paging perspective. Okay, we could ask data independently, but then we are not sure if the data that one system returned are fitting in the same window, the same paging that we are applying. Okay, they could be before, they could be after. So we had to make some consideration in order to properly aggregate the data, filter, paginate, and return to the web UI. So this was the first consideration that made us consider using dynamic BFF to have a single place where to put all this complexity, and then being able to reuse for all the endpoints and in future also in case we're going to have other data sources that are not only LGV Manager that where we should apply the same data aggregation logic. Then the second consideration that pushed us to use the dynamic BFF here was also for, let's say, to allow projects to make customizations. Okay, the peculiarity of dynamic BFF is to be dynamic, as the name suggests. So dynamic BFF is an application that is able to load scripts, and these scripts are defined with a dynamic specific language. And the scripts define in our, I'm not here, let's say, describing the whole scripting language or the whole dynamic BFF functionality, but I'm giving an overview. But let's say via scripts, we can define new endpoints. Okay, new REST endpoints. And the scripts can be loaded dynamically from the dynamic BFF. They are compiled dynamically, so the user that develops the script doesn't need to write the script, build and deploy binaries. It just has to deploy the script itself. And it's quite easy then to build new scripts, deploy them, or modifying existing scripts. A simple restart of the dynamic BFF allows to reload, compile, and make the endpoint defined in the scripts available. So here on the left, you have, for example, some of the scripts that are already provided with the product, and are the scripts that we have been working on to, let's say, define all the endpoints that now replace the LGV system BFF. Okay, in the center of the page, this is an image that, again, I took from the developer guide, so you can see the same in the developer guide, and you can read a lot of more information there. But here in the center of the page, we have an example that I wanted to show you, and some definitions for what we discussed before. So, for example, here, when you see the get, so when we read the data, you see that the system ID is always clustered. So it means that we, as I was saying before, we are able to read the data from both systems at both or all the systems at the same time, or to filter for some specific systems. For post, so that here means web UI actions, like I need to pause the battery missions. Here, the system ID must be single, okay? It cannot be clustered. We need to provide a specific system ID. Okay, then here in the example, a quick overview. This is an example. Here we have an example of a script that is defined, as I was saying, with the DSL. And here we are going to define, okay, that this is a web API, and then in particular, where the path where the web API is exposed, and then in particular, let's say here we are going to define that this is a get, okay. This is a get that has some permission. The alias, is, if I'm not wrong, is just used inside the scripts to be able to reuse this get. And then basically what we do here is to retrieve some data from LGV Manager. So here, as you can see, we defined the default data source, but then here we are using this object, LGV Manager, that is an object, let's say, that the system provides, the SMILE80 provides, dynamic BFF provides, is injected, and it represents basically the WCF of the LGV Manager. So here we are able to make calls to the WCF of the LGV Manager. As you can see, we are invoking like if it was only one, but actually, depending on the system ID that we provide here, we are querying all or some of the WCF of the LGV Manager that are part of the system. Okay, the system ID here, it's again a keyword, and the fact that we have the inherit keyword together means that dynamic BFF try to look for the system ID in the query string or the body of the request. So there are some predefined places where the system ID can be provided from the web UI. In case it is present, then it is provided to the WCF for for the query. So we are going to query only the WCF that correspond to that system ID. In case it's not provided, then it means it's an aggregate query, and then the dynamic BFF it's gonna query all the LGV manager. It's gonna aggregate the data and return to the caller. Okay. Then here at the very end, we also define the behavior we are going to have in case of success or in case of failure. Okay. Okay. So this was the overview about dynamic BFF. For sure, you can find more information in documentation. And there is also training that was suggested in the invitation of this meeting that is about handheld, if I'm not wrong, but it also describes in details the dynamic BFF. Just to make a summary, dynamic BFF here was introduced to make aggregate query across systems, okay, or to be able to select the system where to execute an action. Okay. Then we started in the very first slide of this presentation discussing about the fact that multi-system was introduced to allow to, let's say, deploy new part of the warehouse incrementally and independently from existing parts or and existing fleets. Here in the picture, I showed you then the case where we have two systems. Okay, so in the picture on the left, let's say that the first system is in charge to handle the fleet that is moving inside this area of the warehouse. On the right side, instead, we have another system that is in charge to handle the fleet that is moving in this part of the warehouse. As you can see, the two layouts look identical, except for the fact that, because they both have the same background. This is one of our constraints. So every layout that we define in a multi-system environment should have the same background. They should all share the same reference system, so the same coordinates. But then they can have independent definition of segment, routes, station, operation points, and whatever. Okay, so the first layout here on the left only has to define everything is required in this area. So again, segments, stations, operation points, etc. And should not care about anything about the area that is handled from system 2, and vice versa. Okay. The fact that we need to have a common background is given from the fact that from a web UI perspective, we are gonna always have in this first version of multi-system a single layout. So when we open the web UI, we know that we have the 3D and 2D visualization of the layout. That's always only one page that will show all the information from all the systems. Okay, so that means that we are gonna show a background, and then on top of that background, we are gonna show all the information coming from the two, in this case, the two fleets. Okay, like in the case of Red Bull, all the information about the existing warehouse and all the information about the new part of the warehouse where we are gonna deploy, let's say, the layer picking. At the moment, even though we discussed about it and we recognize that could be useful functionality in the future, but there is no support for configuration that allow to, let's say, to perform translations on rotation on coordinates. So this is why we need to have the same reference system on all the systems that we deploy. Okay, so really the x the point where the origin point on system 2 and the origin point on system 1 needs to be the same, so that the system is not required to apply any rotation or translation of coordinates. One important aspect about this is that the two layouts need to really be independent. So we saw in the first slide that from an architectural perspective, we are going to have multiple instances of SMART. Having multiple instances of SMART means that one instance will handle a subset of the LGVs that are in the warehouse, and the other instance will handle another subset of the LGVs that are in the warehouse. And each instance of SMART is managing the traffic of its own fleet, but it's not aware about the traffic or the information about another fleet. Okay, they are completely independent. This means that we need to keep independent also the layout, let's say, so the segments that we are gonna configure in the different systems. Why this? This is why, in case we configure a segment on system 1 and a segment on system 2 that share, let's say, the same physical space, so they overlap in the real world, then the two LGV manager, the two smarts could allocate that same segment at the same time to different LGVs, and this could lead then to collisions in the real world. Okay, so this means that the configuration we do on each subsystem must be physically separated, so we cannot have crossing or overlapping between the routes, the segments that we define in the two systems. So we cannot have intersection. Okay. Let's say in a context like where we install the multi-system in a sort of multi-building environment, like in Marchese, this is, let's say, more natural. So we have different buildings. Each building is going to have its own segment and routes. They are physically independent, so we do not have the risk to have overlaps. In other environment like Red Bull, where we are gonna instead configuring an area inside an existing plant, we need to take care of this aspect, and we need always to keep a separation between the two systems. For example, by means of conveyors that allow to configure stations where we can exchange materials from one system to the other. Then we're gonna see some configuration for the exchange station later on. Another aspect that I wanted to mention, now that I mentioned multi-building, is that we also recognize that having a single layout in the web UI fits better in a use case like Red Bull, where we have a single warehouse, and so it's natural that we want to see the ends that are added in the warehouse moving in the same layout together to the existing LGVs. That's a bit less natural in case of multi-building, where you have two buildings that are independent, and there could be the requirement to see the building also independently. but at the moment it's something that is not supported by the product. So the layout is only one, and also in case of multi-building, we need to have a single background on the same reference system, and we are gonna see in the layout page all the RGVs and all the active locations, for example, from all the buildings that we configured. It's a limitation, but say it's there at the moment. Now let's move to the configuration. I think that we saw already something in the presentation from Antonio, but we're gonna take a look in details. And let's start from the LGV manager. Let's start also from the assumption that all these configuration that I'm gonna show, let's say, are already done during installation. So usually you do not have to touch this configuration and make changes, but it's to show you what's new and where the system ID, let's say the system had an impact in the configuration to better understand the system. So first of all, here on the top left, we have this new key in the LGV Manager configuration that is System ID. And actually, it's not really a new configuration, but it replaced an already existing configuration that was called sender. The sender was used, and now the system ID is used to populate the messages that are exchanged with STM. If you look at those messages, you have a part that is the header part and the part that is the body. In the header part, there is the sender and the receiver. And when LGV Manager sends a message, it puts the value that before was in sender and now is in system ID in that key of the XML. We replaced with system ID to be, let's say, compliant with the terminology in multi-system and also to reuse it in some other parts, like here, we're gonna see in a minute. Another part of the configuration we need to take care is the default prefix for the tasks. You know that each instance of task handler in STM have a different prefix for the tasks, and this is configured both in STM and in LGV Manager. Here in LGV Manager, we have to pay attention to configure a prefix that is unique across all the systems. Okay, we should not share the same prefix among two different systems. It must be unique. Then LGV Manager also has a new configuration now, that is this section event notifier. And this is intended for a new, let's say, way to communicate between LGV Manager and the BFF layout. So beforehand, BFF layout was polling some of the information from the LGV Manager, making calls to the WCF via the LGV system. I do not explain all the steps, but let's say it was requesting this information and was receiving updates on WCF callbacks. Now we wanted to try, because we were introducing multiple systems, and having multiple systems where, for example, a system is already in production and the other one is it's still under deployment, for example, would lead to situation where one system is up and running and the other system maybe is stopped for some minutes. We wanted to make the communication more robust. And we wanted to avoid, for example, the situation where the BFF layouts try to retrieve data from a system, but the system is not alive. And so the BFF layout has to wait till the time the HTTP or the WCF timeout before returning an error. Okay, so we wanted to make this process more robust and simpler. For this reason, we, let's say, reversed the responsibility, and then now BFF layout and dynamic BFF do not pull data from the LGV manager, but it's the LGV manager that publishes events when something changes with this set of event notifiers. These are rabbit events that are sent on topics. They can use from any SMILE application. At the moment, they are used from the BFF layout. So all the entities that are handled by LGV manager, like the LGVs, the missions, the transport requests, and so on, are all the events are published by means of event notifiers. And here in this configuration, you can see that we have a part where we configure, let's say, the RabbitMQ instance we want to send messages to. And then we have some keys that are dedicated to tell LGV manager the frequency each set of events should be published. For example, the LGV update events are published every 200 milliseconds. The mission update events are published every second. What happens from a BFF layout perspective? It happens that when events are received, then the entities on the web UI are updated. When one LGV manager instance is stopped for any reason, that instance stops sending events, and the entities of that instance stops being updated. For sure, we can always see the status, the connection state of each system from the web UI to know which instances of LGV manager are up and running and which are not. The entities that are handled by LGV managers that are up and running are not affected from the fact that another instance of LGV manager is turned off. Then here on the bottom right, then we have a new configuration that is dedicated with the communication with the truck loading, or better, with the shipping functionality in general. So we said that communication between LGV manager, SDM, and truck loading changed because we removed the middleware, and we switched from a queue approach to a routing key approach. So here we adopted a mechanism that was already there with the picking service, and we use a RabbitMQ topic channel instead of the queue channel. And as you can see, this has a different configuration from the queue channels because we can specify the inbound routing keys here. And in the inbound routing keys, in this specific case, we configure the routing key for the load plan updated events and the routing key for the shipment updated events. Both the routing key has a variable part that is configured during installation automatically, that is the system ID. This is intended because what we wanted was that each instance of LGV manager only receive events that are relevant for that instance. So SDM and truck loading service make some consideration about the doctor that is assigned to a specific truck loading, and based on the doctor, are able to recognize what's the handler that is in charge to handle that truck loading activity, so that they can dispatch events on a dedicated topic for that handler, so for that system. It's also possible, let's say, to have a generic configuration with the wildcard, most probably, but that would lead to errors in the LGV manager that tells that he received an event for a door that he doesn't know. So it was just better to specify the system ID and to be able to filter the events that are only relevant for an instance of LGV manager. For sure, the system ID that we configured here on the top left shall match the system ID that we are going to configure here in the routing keys. It's the same value. Okay, this everything from the LGV manager configuration perspective. Let's move to STM. So STM didn't require major reworks to support multi-system because STM it's by nature already designed to be able to work with multiple handlers. If you think about it, STM is already able, for example, to work both with the LGV manager and with the HDSM. That basically are two handlers, and we can see them somehow as two different systems. So we have been able to leverage the functionalities from STM also to add new systems like new LGV manager instances, new task handlers, basically from an STM perspective. But we had just to apply a specific configuration. In particular, from a dispatcher perspective, here we can see that the SMILE to LGV manager dispatcher now changed the dispatcher type. And we moved from a queue dispatcher type to a queue dispatcher multiplexer type. This is because every time we send a message to a task handler that is an LGV task handler, basically, we want to be able to decide based on the receiver name on what outbound channel we need to go to send those data. So here, then we see that the dispatcher STM to LGV manager is now configured in the dispatcher multiplexing with two rows. The first row is for the receiver name system1, we called it in this way, in this configuration, and messages that are handled from this dispatcher with this receiver name, with the system2 receiver name, are going to be sent using the outbound channel LGVM-sys1. Then we have another row for system2, same configuration. So when receiver name is system2, then the outbound channel is LGVM-sys2. But the dispatcher is the same, as you can see. These receiver names shall match with the task handler names that we have in the task handler configuration. So in a multi-system configuration, we have two task handlers for LGVs. And here you can see that we have task handler 1 that has name sys1 and task handler 201 that has sys name sys2. They are the two task handlers for one fleet and the other. These same ID and names that we have in the task handler table shall match also the configuration that we have in the message handler. An important thing to mention here is also that these system, these sys1 and sys2 and that are configured here and here, basically are the system ID that we also saw in the LGV manager configuration. Okay, they must match, they must be the same value. Now, always from an SDM perspective, we configure the database, but we have to remember that we have also the SDM application, because before we mentioned the outbound channels, the outbound channels are configured in the SDM application. And here in this example, we have two systems, and the outbound channel shall match the values that we have in the dispatcher multiplexing table. In this configuration, what's interesting is also the fact that from an SDM perspective, if you take a look, the inbound queue for the two channels is always the same, while the outbound queue from the two channels is different. So the outbound queue is specific for each system, okay? Because we want to be able to send data to one specific instance of LGV Manager. The inbound queue instead is a single inbound queue. So all the LGV Manager instances are sending data to a single queue that then is fetched, is read from SDM. We made this choice to keep the level of concurrency in SDM the same. So you remember at the very beginning we said that now systems can scale horizontally. We can add instances of Smart and LGV Manager. SDM is always the same, but the whole limit that we gave ourselves was the total size of the warehouse, so the total number of missions and LGVs, to be able to put SDM in the same condition as it was till now. We decided also that, okay, we can increase the number of LGVs, but we do not want to process those requests in parallel. We want to process those requests sequentially as we do in a single system configuration. And this is the why of this configuration you see here. Okay. Then the next topic is the exchange station, and this leads us also to the example that we are gonna do together, the exercise. So we mentioned before that smart instances are completely independent. But from an SDM, and so we need to keep the layouts completely separated. From an SDM perspective, instead, we have only one SDM instance, and SDM is able to handle all the containers and all the stations from all the parts of the warehouse. In this case, to configure an exchange station, what we did was to take a container in SDM, so a station. It's called QA01-A. I simply took one that was already existing without defining new station or changing the layout, but just to show you how to configure a station that is an exchange station. And then what I did was to assign one operation point, so on the system 1, and one operation point on system 2. These are known both by SDM, but from a smart perspective, each instance of smart knows only one of them. Okay, system 2 only knows entqa01, system 1 only knows b19w036. Then what we're going to do is that we're going to configure this operation point for system 1 with the drop enabled, and in system 2 with pick enabled. An important set of parameters that we also have to configure here is the unit identified, so to trust the tracking that comes from the RGB manager in case of active location. The self-directed to allow mission that are starting from the RGB manager with the status message, and the sub-inventory also to allow SDM to trust the field to notify a pallet was moved. Okay, so SDM will accept requests, let's say messages with the tracking info for a pallet that is in a new location than the one that SDM was knowing before. One important thing in this example, it's always to remember that let's say this station needs to be physically isolated among the two systems. Okay, in this case, we cannot have a location where an LGV from system 1 simply drop and then an LGV from system 2 simply pick, for example, at the ground. But we need to have something that physically make a separation here. So in this scenario, for example, if we imagine Red Bull with layer picking, we can imagine a conveyor. We make a drop on one side, then the pallet is moved, then an active location on the right side notifies that the pallet is available and we can pick. Okay. So here I have, let's say, a small script that does what we just discussed. Okay, so basically it takes the container ID for the container we want to use as an exchange station. It set this container with the properties that we just mentioned. Then it enables the pick and disable the drops on the operation point that is on the system 2 side, the one from the ANS. And then because in my layout here, I was not having an operation point valid for system 1, I just pick an operation point anywhere from system 1, and I'm simply assigning that operation point to the container. Okay, so in the end, the final result is that when an LGV from system 1 drop a pallet on this operation point, then the pallet is inside the container and can be picked up from the operation point that is on system 2. Another important step here is that I'm also gonna add this station to the simulation offering station list. Okay, and this is required for simulation because then LGV manager, when we set the active call, is able to get the LPN and to, let's say, to populate the tracking info correctly. Okay, let me switch a second to the presentation to my screen so that I can show you the environment. Okay. Okay, here I'm opening the web UI, just a moment. while the web UI is opening, let's take a look to the current situation of this environment. So here, okay, I already queried, but I do again. Here we can see the configuration of and in O1. Okay, this is the in the current scenario, the exchange station that is used to move pallets from system 1 to system 2. It's already existing. Okay, we want to configure a new one. But before, I want to show you what happens here if the portal is opening. Just a second. Let me try to open it again. Okay. To move pallet, here I'm going to use one functionality that is called refill. The refill functionality comes from the layer picking, so I'm not entering into the details of the functionality itself. There is a training, if I'm not wrong, about layer picking, so you can see it more in depth there. But here we are just using that functionality to move pallet from one system to the other. So, and this is the page where we are going to create refills. Then let me open the layout so that I can show you the current, let's say the current configuration, the one that we have seen in the query. We can see also here. Okay, so this is the same system that I showed you in the slides. Okay, so here we have the area handled by system 1, and here we have the area handled by system 2. And when I zoom a bit here, here I have the station that is called end in O1, the one that is already configured in the system. This station has an operation point here for the pick from the ants. These are ants, okay? And the operation point for the drop is not here because you see the layouts are not connected, but we created an operation point somewhere here. But doesn't really matter. When the LGV drop here, then the pallet is in this station here, okay? So let's try to trigger this before changing any configuration. So here I can create a new refill. I say that the refill goes to the area for the system 2. I select the pallet and the quantity. Then let's start it. Okay, the refill is in progress. And as you can see, the refill has one transport order and 2 routes. So the first route is from this location to ant-in, and then from ant-in to another location. And where? The first location, this one, is from system 1. The second location, second location is from system 2. So this is system 2, this is system 1. Then ant-in is our exchange station. Okay. When I go to the layout, and I look at the active missions. Okay, I have few batteries, but I have, okay, this is the mission. Now the LGV is picking a pallet from here, and then it is moving the pallet to the operation point, to the exchange station. As I told you, okay, the operation point, it's not actually physically here, but it's connected to this, okay? The B19W038, if we see at the query, B19W038 is the drop operation point in system 1 for this container. On the other side, we're going to have another operation point, okay? So let's give it a minute so that it can move and drop the pallet there. When the pallet is dropped, we are gonna then pick it up from here. While it's moving, and I can do this so that we can see when it drops. I can also show you some details about the new exchange station that we want to create. So Ent QA01. Ent QA01 is located here. So I'm just gonna reuse a station that is a rack right now as an exchange station, but doesn't really matter. We are gonna just take this station, reuse an operation point that is on this side here, and then assign another operation point that is somewhere here for the drop. Okay, we're gonna do this this job here. And then it's gonna work the same way as Ent 01. Okay, while the LGV is moving, I just take the opportunity to drink some water a second. Okay, LGV is approaching. Then what I have to do next, just to explain, once the pallet is dropped, then I have to set an active call here. Okay, that's the standard procedure. I'm gonna use the PLC simulator from LGV Manager. Remember, this active location here is configured on LGV Manager from System 2. So here I connected to our environment in the machine where LGV Manager from System 2 is configured. Okay, now the pallet was dropped. If we look at the refill order, you see that the first route was completed. Now we are waiting for the second route. When I go to the simulator, I'm in the hand in station. I set an active call in offering. What happens here now is that you see we have now the ant that is gonna it's gonna take the pallet and it's gonna move the pallet then to its final destination that should be Ent A03A. That is one. Okay, I have I think to do it again because the simulator took a different LPN now. Let's try it again to put the station in active call. And let's see if we take the right pallet. Here the refill is still open, even though because we need to take the right pallet here. Okay, now it's moving to Ent A3, so now we are moving to the right location and we took the right pallet. So when this is dropped, then what happens is that the refill order is gonna be closed. And we can reconfigure and create a new one to see the new station. Okay, yeah, this disappeared, it's done, and we saw the whole process. Now, very quick, we want to run the scripts that I show you in the presentation. Okay, that is this part here. Then I have a select just to check the configurations. Let's do it. Okay. Now, when we check the status here of the system again, we can see that now Ent QA01 has 2 operation points, not only one. Okay. The operation point on the system 2 side is the same, we have assigned an operation point from system 1. And this is enabled for drop, this is enabled for pick. What I wanted to do now to be sure that then we are going to use this exchange station is to disable for a moment the drop on the operation point that it was just used. Otherwise, now we have to exchange station. When I create a refill, I'm not sure which one is going to be used. Okay, so let's disable this for a moment. And let's go to create a new refill. Okay. This is in progress. You see that now we are using the new exchange station that we configured, that is end QA01. Okay, as before, the process is going to be the same. I wanted to just show you, maybe I can try to make the simulation a bit quicker, a bit faster. Okay, it's taking the material from here and then it's moving. What I can show you while it's moving to drop is that, let me check here. Okay, here in the active locations, what I already did was from Energy Manager perspective to configure already an active location. Okay, this I didn't show you because this is the really standard procedure. You just have to configure a PLC station with all the signals to have active calls. It is identical to the NTIN. I modified the provider, all the stuff that you already are familiar with. But now I have to fire the active call from this station, not from NTIN. Okay. So when the pallet is dropped, then we can fire the active call from here. One thing that we can also try to look at, and that I would expect, is that when we drop here, we're going to see a pallet, okay? Because we connected this operation point. Let's say, let me do it a circle. Okay, this operation point here is connected now to this container here. And then here we have another operation point for the pick operation. Okay. So let's see. Okay, the first part of the mission was done. You see here we have a pallet appeared in this container from an STM perspective. Now let's fire the active call here. And then we finished the example. Okay, you see now the ant is gonna pick. And once they are picked, the refill order is gonna be closed. Okay. Okay, and is moving to 104. That is the final destination of our refill order. it was dropped, and yeah, the refill order is closed. Okay, this was the whole example. So I can switch back to the presentation. Just a moment. Okay, so we were here. What I wanted to mention is that there is also another possibility, at least another possibility that we wanted to show you for an exchange station. In this kind of configuration, that was actually the one that we started from and we wanted to show you. We do not have only one container from an STM perspective, but we have two separate containers for the two systems and two separate operation points for sure for the two systems. Okay, so the idea is that when GV drops a pallet here, then the pallet is in this container. Then in the real world, a conveyor would move the pallet from container 1 to container 2, in the system 2. And then here, an active call would fire, and with the flags that we configured in STM would accept when HV manager sends the tracking information that the pallet was moved from this container to the other. I didn't show you this in the example, even though it's the same. Let's say you can do it by yourself eventually, just because it's not supported out of the box from the simulation. Okay, so if the pallet is dropped here in this container, then when HV manager calls the let's say the simulator to get the LPN that is on this available for this operation point, then nothing would be returned right now. You need to make some rework on this, most probably on this store procedure, to move the pallet from one container to the other. Okay, but the idea was to be able. I mean, this scenario is for sure supported. Okay, this is the last slide, and it's about the known limitation and constraints that we have in multi-system today, that it's our first version of the functionality. Okay, first of all, what we gave as a constraint was to have resource type names unique across systems. Okay, so for example, in a use case like Red Bull, where you have single fork and double fork in the existing plant, and in the new part of the warehouse you have ants that are nowhere else in the warehouse, then it's simple. You have a new resource type and it's unique across the systems. This can be we have to pay attention in, for example, in a multi-building scenario where we have one building with single fork and the other with single fork. We have to give unique names like single fork 1 and single fork 2 or whatever we prefer, but they must be unique. Same for the dock doors, in case both system or more than one system handle the doors, for sure, the dock doors. In Red Bull, for example, that's not going to be the case again. The dock doors are already, if I remember correctly, required to be unique because there is a constraint already on the database with a unique index. And then also the entities in HV Manager, what we suggest is to have them with unique names, like the active location, the battery chargers, the reflector areas, to make them, let's say, distinguishable also by names across the systems. This last thing is more related to reports, where things can get a bit confusing in case we have the same name for entities that are from different systems. Then, from an STM perspective, when we configure the containers hierarchy in STM, we have the possibility to configure different container types, like the warehouse, the area, and so on. A scenario that it's not supported at the moment is to have multiple warehouses and fleets assigned to different warehouses. The constraint that we are giving is to have one warehouse and then different areas per each system, for example, if we need to do that. This is directly connected to the fact that on Web UI we still have a single layout page. Okay, that layout page only shows information from one warehouse at a time. So in case we have multiple warehouses in the configuration, we are not going to see the information from one system or the other, depending on the filter that is configured on the layout page. So this is why we have this constraint on the containers hierarchy. Then at the very end, the containers names, this is a more relaxed constraint, let's say, but it's more a suggestion, should be configured with unique names. It's not a strict constraint because actually STM use IDs for all its own reasoning. So you could already have two containers with the same name. But let's say we suggest to apply this constraint and this methodology at least to avoid to get confused. So if you give the same name to containers from different systems, there is the possibility that then information on web pages are not that clear. Okay, this was this last slide. So if there's any question, I'm here, or let's see, otherwise Giorgio, Enrico, we are done for today.
Can I make a simple question? I don't know if it has a simple answer.
Sure, Andrea. Yeah.
When you describe the two layouts and the constraints, you said they must have the same background. What do we mean for background?
Okay. The background is, let's say, in the layout terminology. When you design a layout for Smart, it has a background, okay, an SVG background. On top of that background, then you design the routes, the segment, and whatever. What we mean with that constraint is that we have to reuse really the same background, the same SVG for both layouts, for all the layouts.
Okay. Yeah. I am not an expert of this part. I don't know if it was a clever question, but I didn't have this information.
No problem. No problem.
Thank you.
Welcome. Okay. I can stop the share, maybe. And I don't know, Giorgio, if there's no other question, we have finished for today, I guess.
Thank you. Thank you, Giovanni.
Okay.